Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0103, indicates a high voltage issue in the mass airflow MAF sensor circuit of a Honda Fit from the years 2015 to 2020. The MAF sensor is a critical component responsible for measuring the volume and density of air entering the engine. Its accurate functioning is essential for the Engine Control Module, ECM, or Powertrain Control Module, PCM, to regulate fuel injection and maintain optimal air-fuel ratios. This code can lead to engine performance issues, increased emissions, and reduced fuel efficiency. Correctly diagnosing and addressing this code involves understanding the sensor's readings, potential electrical faults, and the relationship between various components in the vehicle's air intake system. As a first step, it is important to verify the problem by checking sensor parameters using the Honda Diagnostic System, HDS, before performing any physical inspections or repairs. The MAF sensor, located in the air intake duct, measures the amount of air entering the engine, providing data crucial for optimal air-fuel mixture calculations. The Powertrain Control Module, PCM, sometimes referred to as the Engine Control Module, ECM, processes this data to control fuel injection accurately. The MAF sensor works closely with the air intake temperature, IAT sensor, which also resides in proximity, analyzing the temperature of the incoming air to assist in precise fuel calculations. Any high voltage reading, typically above 4.89 volts for the MAF sensor, suggests potential electrical issues that could be caused by faulty wiring or a malfunctioning sensor itself. Additionally, connections between the MAF sensor, IAT sensor, and the PCM must be intact to ensure reliable signal transmission. In diagnosing DTC P0103, awareness of these components and their locations is vital, as they can affect engine performance and fuel efficiency. Several possible causes can lead to DTC P0103 being triggered. A faulty MAF sensor itself is often the primary suspect. It may fail due to wear, contamination, or internal damage. Additionally, bad wiring your connectors, specifically in the circuit connecting the MAF sensor to the PCM, can cause high voltage readings. This could manifest as shorts or breaks in the signal wire, which can lead to incorrect monitoring. Internal failure within the PCM is also a possibility, affecting its ability to interpret the MAF sensor's data accurately. Lastly, a poor ground connection can disrupt the electrical circuit, causing abnormal voltage levels. Each of these issues needs to be examined carefully to pinpoint the exact source of the problem and ensure successful resolution. When DTC P0103 is present, various symptoms can be observed in vehicle performance. Erratic engine performance may manifest as stalling, hesitation, or rough idling due to improper fuel-air mixture caused by incorrect readings from the MAF sensor. Drivers might also notice reduced fuel efficiency since the PCM may overcompensate for incorrect airflow readings, leading to excessive fuel consumption. Furthermore, this issue often results in increased emissions, making it likely that the vehicle may fail emissions testing due to poor engine combustion. A crucial indicator that usually accompanies this code is the illumination of the check engine light, which prompts the driver to take further diagnostic actions. Understanding these symptoms can facilitate quicker identification and rectification of the underlying faults related to P0103. The first troubleshooting step for diagnosing DTC P0103 involves verifying the problem through the Honda Diagnostic System, HDS. Start by turning the vehicle into the on mode, which powers up the vehicle's electronic systems without starting the engine. After waiting for a period of 2 seconds, use the HDS to check the current signal conditions of the MAF sensor. Specifically, you are looking for a voltage reading exceeding 4.89 volts. Should the current conditions align with this threshold, it confirms the existence of the failure. If the signals do match, the problem is duplicated, prompting the technician to proceed to the next troubleshooting step. Otherwise, if there is no match, there may be intermittent failures or loose connections to inspect. This step emphasizes the importance of utilizing the HDS to gather accurate diagnostic data, setting a foundation for effective troubleshooting. In troubleshooting step 2, the focus shifts to assessing the integrity of the vehicle ground module (VGM) wire, which is essential for proper communication between the MAF sensor and the PCM. Start this step by turning the vehicle to the off lock mode. After ensuring that the vehicle is inactive, jump the SCS line using the Honda Diagnostic System to create a service mode. The next action is to disconnect the connectors from both the MAF sensor, IAT sensor 1, 5P connector, and connector B of the PCM, 51P. This disconnection allows for a continuity check between the specified test points. The overall objective of this step is to establish whether there is continuity in the circuit. If continuity is present, it denotes that the wiring is intact. If not, one must repair any open circuits in the VGM wire connecting the PCM to the MAF sensor to resolve the DTC P0103 issue effectively. The final step in troubleshooting DTC P0103 involves assessing the internal circuitry of the powertrain control module, PCM. Start by reconnecting the PCM connector B, 51P. Once reconnected, use a continuity test to check between specific test points: the female terminal number 2 of the MAF sensor / IAT sensor 15P connector and the body ground. This test verifies whether the PCM's internal circuit is functioning as intended. If continuity is confirmed, it implies that the internal circuit of the PCM is operational, which signals the need for a replacement of the MAF sensor or IAT sensor 1, as they may be malfunctioning. Conversely, if continuity is not established, you should check any relevant and authorized service information pertaining to the DTCs in question, or consider substituting with a known good PCM. This latter action would allow for validation. If the DTC P0103 resolves, the original PCM may need replacement. After completing all necessary repairs regarding DTC P0103, it is essential to verify the effectiveness of the fixes. Begin by clearing any DTCs using the Honda Diagnostic System, HDS. This process removes any stored codes from the vehicle's computer, paving the way for a clean slate. Following this, take the vehicle for a test drive to allow the ECM to reevaluate the operation of the MAF and assess any potential changes in performance. During the test drive, monitor live data using the HDS to observe any changes in MAF readings and general engine performance metrics. The ultimate goal is to check for the reoccurrence of the DTC P0103. If the code or related symptoms return, it indicates that further investigation is necessary. This verification step is crucial to ensure that the fault has been correctly identified and resolved. Preventive maintenance plays a vital role in minimizing the likelihood of encountering DTC P0103 in the future. One key aspect is to regularly check and replace the engine's air filter, as a clogged or dirty filter can strain the MAF sensor, causing it to read inaccurately. Another important practice is to routinely inspect the wiring and connectors associated with the MAF sensor and PCM for signs of wear, fraying, or corrosion. Catching these issues early can prevent more serious electrical faults later. Additionally, periodically cleaning the MAF sensor using appropriate cleaners can help maintain its function and accuracy over time. Implementing these preventive measures ensures the optimal performance of the vehicle's air intake system and prolongs the lifespan of critical components. In conclusion, DTC P0103 highlights a high-voltage condition in the MAF sensor circuit, which can adversely affect engine performance and efficiency if not addressed promptly. Understanding the critical components involved, such as the MAF sensor, PCM, and IAT sensor, is key to effective diagnosis and repair. Following a systematic troubleshooting process ensures accurate identification of the root cause, whether it be the sensor itself, wiring issues, or internal circuit problems within the PCM. After rectifications, thorough verification methods are essential to confirm that repairs have resolved the issue. Finally, implementing ongoing preventive maintenance can help mitigate future occurrences of DTC P0103, enabling a smoother, more efficient driving experience. Please like and subscribe to the channel. See you next time!